Morning class, today we're going to talk about one-to-one and inverse functions. So we're going to start off with what is an inverse. As you can see here at the very beginning, given that f of x is equal to x plus 4, follow the following relation. Well, if x is equal to 1 and 1 plus 4 is equal to 5, then f of x is equal to 5. 2 plus 4 is equal to 6. 3 plus 4 is equal to 7. 4 plus 4 is equal to 8. So we get the set of coordinates 1, 5, 2, 6, 3, 7, and 4, 8. And you get that just by adding 4 to the x value. It reads on to say, the inverse function of f, denoted by f of -1, is found by interchanging the first and second coordinates of each ordered pair. So basically, the inverse of f of x is going in and changing the x and y's and flipping them, just like what you see before. So when he goes on to say, well, let's talk about domain and range of inverses. Well, domain of f is equal to the range of f of its inverse, and the range of f is equal to the domain of its inverse. So they're just they flip. As we see, inverse is going to be its opposites. And so we get into is talking about inverses and how we undo an inverse. The inverse functions of f and f of -1 have the effect of undoing each other. So for example, the inverse of plus would be minus, the inverse of dividing would be multiplication, the inverse of squaring something would be square rooting, and so that's kind of undoing something. Two functions of inverses of each other if, and this is what looks like a composite function here, guys, f of the inverse of f is equal to x, and so forth. And you saw that on day 1 when we talked in 5.1, the equation that we dealt with, when you plugged it in, you end up getting it equal to x. So it goes on to talk about instructions on how to finding inverses algebraically. So the first place is find the inverse of the equation of algebraically. First is replace f of x with y, interchange x and y, the variables x and y, solve the new equation for y, and your new equation will be its inverse. And so let's scroll down some more. Let's verify inverses by algebraically. Well, you can determine that two equations are inverses of each other if you take the inverse equation, plug it into its original equation, and you simplify it and you get x. So let's go ahead and look at finding the inverse of f of x is equal to the square root of x minus 4. And then we're going to verify it. So we go through just like we did. Step 1 says take out f of x and change it out and write the rest of the equation. Interchange those out. So we interchange them out. Oh, this is here. Sorry guys, I had to get rid of that box. Okay, so we take f of x out and put y in again. Then you go ahead and reverse or interchange the x and y, and we resolve for y. So in doing this, we're solving for y here, so we go ahead and undo everything. So you square both sides to get rid of the square root, and then finally you're going to add 4 to both sides, and you're left with y is equal to x squared minus 4. And so let's check to see if we're right. So we check by plugging in our new equation. This is our f of -1 here. And so we plug that into the original equation. So f of x squared minus 4 is equal to square root of x squared minus 4, and finish off the rest of the equation. No, I'm sorry, this is plus 4 here, which means that this would be plus 4 here, and that's plus 4 there. And then we finish off the equation with minus 4 here, part of the equation. So then we go ahead and simplify. Well, the 4's cross out. You're left with square root of x squared, which ends up being just x. And so as we saw before up here, if f of f -1 of x is equal to x, then it's going to be the inverse of each other. So that's proven there. So it says which of these functions is the inverse of 7x plus 4. So we take this equation, set it equal to y instead. So let's check. Y is equal to 7x plus 4. Interchange x and y. Then we go ahead and resolve for y again. Subtract 4 from both sides. And then we divide by 7. And you get y is equal to x minus 4 over 7. And it looks like this is our answer. Alright, so let's move on. Okay, so we're going to want to talk about graphs of inverse functions, as it starts off saying if the point AB lies on the graph of f, then the point BA must lie on the graph of the inverse of it. Talking about before when we flip the coordinates. How did inverse look on a graph? The graph of f negative 1 is a reflection of the graph of f along y equals x. In other words, the line y equals x is a line of symmetry for two inverse functions. So let's dive in and let's see what that talks about. So the sketch of the graphs of inverse functions, then wants to go ahead and sketch one at x squared plus 1 for all x values that's greater than or equal to 0. And then also do it in the same coordinate plane for the square root of x minus 1. So let's go ahead and do a t-chart first to help us out with this. And so we create a t-chart, x and f of x. And as you can see here, we'll just go through using all the values that are greater than or equal to all the x values that are greater than or equal to 0. So we'll use 0, 1, 2, 3, 4. And all we have to do with all these x values is just do exactly what the equation says, which is square it and add 1. So 0 squared plus 1 is 1. 1 squared plus 1 is 2. 2 squared plus 1 is 5. 3 squared plus 1 is 10. 4 squared plus 1 is 17. And so we'll go ahead and graph that. So we have a point at 0, 1. We have it at 1, 2, 3, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, that's going to go off the chart. So as you can see here, we have this type of graph that looks like that. Half of a parabola. So now we go ahead and look at the inverse function, square root of x minus 1, and see what that looks like. So we create another t-chart with this inverse function using the same x values we did before. We're going to plug it into the equation. So we'll take the x value, subtract it from 1, and then take the square root. 0 minus 1 is negative 1 square root. Does not exist. 1 minus 1 is 0. Square root is 0. 2 minus 1 is 1. Square root of that is 1. 3 minus 1 is 2. So square root of 2. 4 minus 1 is 3. So square root of 3. So we'll graph this one. And you see 1, 0. So we go out to here. It's not a good spot. There, and then we go to 2, 1. And then we go to 3 square root of 2. 1, 2, 3 square root of 2. I'll make these better. There, 4 square root of 3, which ends up being a little bit higher. And if you follow these dots patterns, you'll see something like this, which confirms that. And if you look, and I draw a line of symmetry at y equals x, well, y equals x is that line right there. So if you see that there, what you'll notice is the graph is a reflection on it upon that dashed line. And so that ends up showing us that the graph is an inverse of each other. Alright, going to one-to-one functions. Horizontal line test for inverse functions. A function f has an inverse function if and only if no horizontal line intersects the graph at double points. So it's the same thing as a vertical line test, except now instead of going vertical, now we're going left to right. What does 1 to 1 mean? A function f is 1 to 1 if each value of the dependent variable, y, corresponds to exactly one value of the independent variable, x. Function of f is an inverse function if and only if 1 to 1. So it says this: if I have for every unique value of y that corresponds with every unique value of x, then it's 1 to 1. There's no repeats, absolutely no repeats. The function f is an inverse of it, then that can work. Y values cannot repeat, is what it's trying to say. So if we look here, use a graph of the function f of x equals 3 minus x over 2, and the horizontal line test to determine whether the function is an inverse. So if we look here at a graph of this, we'll go ahead and see. So if I plug in, again, let's just do a t-chart here, x and f of x, and let's see if this is actually a 1 to 1 function. So if we look at this, you'll notice that this is actually a linear function. We know it because there's nothing special about the x there. So we just go ahead and write this out normally. Like that. Basically, it's instead of putting everything over 2, we just say 3 over 2 minus 1/2 x is what we have. So 3/2 is our y-intercept. I'm not even going to do a t-chart. I'm just going straight to this. 3/2 are y-intercepts. And we end up going and using the slope of negative 1/2, which means you go down 1 and then over 2. You go down 1, over 2. Or vice versa. Up 1, over 2. So you end up seeing this type of graph here. Now, let's determine if it's 1 to 1. Well, you do that by checking a vertical line test. So we take it and we go, okay, I can do this way and only cross it once. I can also do it this way and only cross it once. So this function is 1 to 1. Alright, so we have some exercises here to check to see if these are 1 to 1 functions. So we'll go ahead now and graph this, and it's x cubed. Well, if we were to again use a t-chart, we'll use negative 2, negative 1, 0, 1, 2. I don't have enough room to put on top, but you get the idea. So cubed, negative 2 times negative 2 times negative 2 makes negative 8. Negative 1 times negative 1 times negative 1 makes negative 1. 0 cubed is 0. 1 cubed is 1. 2 cubed is positive 8. Okay, so we go ahead and label these points. So there's one there. Negative 1, which is there. The origin. 1, 1. And 2, 8. So you end up with this type of function, which we've already seen before. Cubic function looks something like this. Well, looking at it, you can tell that it passes a vertical and a horizontal line test. So to show you, if I was to draw lines this way, only crosses once. If I was to draw lines horizontally, only crosses once. So that means that this is a 1 to 1 function. How about x squared minus 2? Well, if we look at x squared minus 2, that is going to be a quadratic, and it's been shifted down 2. So we end up having a vertex at 0, negative 2, and then we go ahead from there and we end up squaring everything. So 0, negative 2 ends up being there, and ends up going a little bit higher, and you end up seeing this type of function here. Well, as you can see, there's your parabola. If I was to go through and do a vertical line test, it passes. So it is a function. However, it is not a 1 to 1 function, because when I go horizontally, I am crossing it twice, which means that I cannot do an inverse function. It does not have one. So when that violates that type of test, then you go ahead and find out that this function is not one-to-one. So then we go through and look at the other one, the last one. With the last one, what they've added is a type of rule saying only use values that are greater than or equal to, only use the x values greater than or equal to 0, which means we're only going to use -2, we're going to use -1, +1, -1, and then +2, 3, and so then you see something like this, which you know now will pass a vertical line test and pass a horizontal line test. So this is an inverse function. And so now we go ahead and finish our instructions, which says if it is, then go ahead and find the inverse equation. So we go and do that. And what you see here is we'll go to the equation, take out f of x, put y, exchange them here and resolve for x, or resolve for y, which means in order to undo this, we do what's called a cube root. And so you get this type of equation. Y is equal to the cube root of x. Going on to part C, finding that one. Again, take out f of x, put y, write out your equation, exchange the x and y, resolve for y. So we add 2 to both sides, and then we take the square roots. And you're left with y is equal to square root of x plus 2. However, we have to follow the condition that was given to us in the original f of x. So, for all values that x is greater than or equal to 0. Alright, so it goes on, number 6 says find the inverse of 4x minus 9. So we go in and exchange and resolve. And divide by 4, and you get y is equal to x plus 9 all divided by 4. And find the last one says find the inverse of f of x of the square root of 10 plus x. So we'll go ahead and again go through the steps. Take out f of x, put in y, square root of 10 plus x, exchange them, and solve. So first thing is square both sides. And subtract 10. So you get x squared minus 10 equals y, and it says domain restriction for f of -1. You have to use the same thing, where x can only be greater than or equal to -10.